All right, y'all. So 7.1 deals with symmetry. And y'all, symmetry is when you can cut something down the middle and both halves look the same. So we're going to look at symmetry with our graphs. So the first symmetry we're going to look at is when something is symmetric to the y-axis. All right, so for something to be symmetric to the y-axis, if folding a graph over the y-axis and the graph lands on itself. So let's see. I want to draw me a little graph real quick. So there's my X and Y. So say I had a little V-shaped graph coming out of the center of my graph there. So this would sort of be like an absolute value graph that we was playing with. But y'all, if I take this graph and I fold that graph over the y-axis here, if I fold it over, the right side of this graph will land on the left side of this graph when I fold it over. And that's how we're going to check and see if something's symmetric to the y-axis. Remember, take the graph, fold it over. If it lands on itself, symmetric to the y-axis. The second thing we look at is whether something is symmetric to the x-axis. And y'all, we're going to check that the same way, except this time we're going to fold the graph over the x-axis. So if folding a graph over the x-axis and the graph lands on itself. All right, so let's see. Say I had a graph that came out and curved up, and then the bottom came around and curved on that bottom. So to be symmetric to the x-axis, I got to be able to take this graph, fold it over the x-axis, and when I fold it, this top half lands on the bottom half. Okay, so symmetric to the y-axis, I fold over the y-axis. Symmetric to the x, I fold it over that x. So the third type of symmetry. Now notice I've used up both the lines, so I'm not going to be able to fold it over the y-axis this time or the x-axis. So the third symmetry we're going to look at is what we call symmetric to the origin. Y'all remember the origin is the center of the graph where the x and y axes intersect each other. So to be symmetric to the origin, if turning the graph 180 degrees. So that means if I have a graph and I turn it 180 degrees, I'm going to be turning it upside down, basically. So if turning the graph 180 degrees and you get the same graph. So let me show you what symmetric to the origin would look like. So to be symmetric to the origin, you're going to have a graph sort of come up, pass through the origin, and then go uphill. So y'all, you see how this graph looks? It's going uphill, left to right, passing through the center. Now watch this. I'm going to turn this page 180 degrees. And if you look at my graph, it's still going uphill, left to right, passing through the origin. This graph looks the same as it looks when I had it normal. So if you can turn it 180 degrees, which means basically upside down, and you have the same graph that you started with, symmetric to the origin. Now, here's another thing. Graphs that are symmetric to the y-axis, we call these even functions. Another thing about even functions, they cross the x-axis. An even number of times. If it's symmetric to the origin, we call that an odd function. And an odd function crosses the x-axis an odd number of times. Now, x-axes, if they're symmetric to the x, they can't be even or odd, because remember, if it's symmetric to the x-axis, it fails the vertical line test, which means it's not even a function technically. So symmetric to the y-axis is even, symmetric to the origin is odd. All right, y'all, so on these examples, we're going to determine if the graph is symmetric to the x-axis, y-axis, and or the origin. All right, y'all, so let me draw number 1 here. All right, so let me see. This one sort of does uphill on the right side. And then it comes down like that. On this side, it comes down and up. And then goes off to the left. So the first thing I would check is my y-axis. But y'all look at this. If I fold this graph over the y-axis, this top part hits up here, and then the bottom part comes down. So it does not land on itself. So it's not symmetric to the y-axis. If I fold it over the x-axis, well, this graph is not hitting itself. This part just hits down here, but it's not landing on itself. So it's not symmetric to the x-axis. So y'all, the only thing I got left is to check if it's symmetric to my origin. So y'all see my graph. I'm about to turn this upside down. So y'all, when I turn this graph upside down, look at that. It comes down, goes through the center, and makes its humps. So it is the same picture upside down that I have this way. So this graph is symmetric to the origin. Also notice this, it crosses the x-axis once, twice, 3 times. So since that one crosses the x-axis 3 times, it's verifying that this is symmetric to the origin. All right, y'all, I'm gonna try another one with y'all. All right, y'all, so this little graph is coming down, comes down and makes that. And then it does the same thing on the left side, comes down and does that. So any guesses to whether this one is symmetric to the x-axis, y-axis, or the origin?
Y-axis.
Definitely the y-axis. If you take this graph and fold it over the y-axis, the right side lands exactly on the left side. So this is symmetric to the y-axis. Also, we said y-axis was even. Well, y'all, this one crosses over the x-axis 2 times, which verifies. All right, let's see what 3's got in store. All right, so number 3, they got me a point here with a line coming out. The line's coming out the same way, going to the bottom. All right, y'all, symmetric to the y-axis, x-axis, or the origin.
X.
X-axis, there you go. Right, so if I take my graph, fold it over that X, that top half lands on that bottom half. Okay, so now on these 2 examples, they want us to determine visually whether the function is even, odd, or neither. And also number 4, got my X and Y. All right, so this one sort of comes down on both sides. So y'all, even, odd, or neither. So remember, if it's even, it's going to be symmetric to the y-axis, and it's going to touch the x-axis an even number of times. So 2 ways you can check this. First way, notice it's touching the x-axis twice, which makes it even. Also, if you take this graph, fold it over the y-axis, it lands on itself. So that makes this a even graph. There you go. Ooh, y'all, this lesson's gonna be a little tricky for me. So how about I just show you the picture of it instead of me trying to draw this. So I'm gonna zoom this in just a little bit and then refocus. So I'm playing with this graph right here. Is that graph even, odd, or neither?
Odd.
Oh, it's definitely odd. Because guess what? If you took the picture and turned it upside down, first of all, when I turn it upside down, I got the same graph. So that means it's symmetric to the origin, which means it's odd. Also, if you notice, it touches it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. It touches the x-axis 9 times. So that also means that this is an odd function. All right, y'all, so let me unzoom that. So do y'all have any questions out of 7.1? That's all it deals with is those 5 problems. You got 3 dealing with symmetry, 2 dealing with even or odd. Righty, y'all. So 7.2 will be a little more tricky. So 7.2 is going to deal with transformations. All right, let me see here. Straight line. All right, so to do transformations, we're going to take basic graphs and move them left, right, up, down, and we're going to flip them. So the first thing we got to learn are what we call our basic graphs. Okay, so there's going to be about 7 or so of these. So y'all, the first basic graph looks like a line coming straight through the origin. This is what we call the y equals x graph. So if x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. So this is the basic graph of a line. Second basic graph looks like a U. So it comes up looking like a U. That is our parabolas that we've been drawing. And the graphs that make the parabolas are the y equals x squared. Remember, the x squared graphs always made a pretty U-shaped graph. All right, the third basic graph. This is going to be a cube graph. So these cubes come up, cross through the center, and then they go uphill. This is the y equals x to the third graph. All right, I'm just trying to see what all graphs they're using. And x and y. This one sort of comes out and goes slowly uphill as I go to the right. This graph is the y equals square root of x. So it's a slowly uphill graph. All right, next we'll do the cube root. The cube root is similar to the squared graph. The square root. It sort of goes uphill to the right and does the same thing to the left. So this is y equals the cube root of x. Now y'all notice the square roots don't have any graphs on the negative side, because remember, you can't take square roots of negative numbers. Those are those imaginary numbers. But the cube roots, you can take a cube root of a negative number, so that's why the cube root actually goes on both sides. All right, y'all, the next graph makes a V. In the graph that makes the V shape is our absolute value of x. All right, then I got one more. All right, and this graph on the left side sort of comes in and goes down. On the right side, it starts up here, comes down, and sort of follows the x-axis. This graph is the y equals 1 over x. All right, y'all. So these are 7 basic graphs. So make sure you keep these in a nice place, because what we're going to do is take these graphs, we're going to learn how to shift them up or shift them down, shift them right or shift them left, and how to reflect them over the x-axis. So those are the 3 moves we're going to look at on these graphs. So y'all, we're going to start looking at our transformations. First transformation is what we call a vertical shift. So vertical shift will move my graph up or down. So to get a vertical shift, your graph will be in the form of y equals f of x plus or minus b. So if I take my function and add a number or subtract a number from the end of the function, it's going to move me up or down. If b is positive, if the b is positive, it's going to move me up. So say I took an x squared graph and I added 2 to the end of it, that would move my graph up 2 units. If this b is negative, it's going to move my graph down. Okay, so adding a number to the end of a function moves it up. Subtracting a number from the end of a function moves it down. So let me give you a couple examples. Say I had y equals x squared plus 7. That would take my x squared graph and it would move it up 7 units. So this one would move the x squared graph up 7 units. So y'all doing that. So this was my X and Y. And remember when I started, my parabola touched the center origin of the graph. So if I move it up 7, it's going to take my parabola and move it up 7 units. So let's look at one where I maybe subtract. How about the y equals x minus 7? That's going to take this straight line x graph and it's going to move it down 7 units. So this will move the x graph down 7 units. So remember, my x graph went through the center, but y'all, if I move that down 7, it's going to make my line cross down here at -7 instead of at the origin, okay? So adding at the end of the function moves up. Subtracting at the end of the function moves it down. All right, y'all, so I'm going to give y'all a second to write that, and then we'll look at the second transformation. So remember, there's going to be 3 transformations. All righty, so let's look at our second.
So did you just start at -7 and then draw the line?
Yeah.
Like you just started on the x-axis on -7 and then drew it?
So technically, if the line went through the center like this, and when you moved it down, it'd be at -7 on the y-axis.
Okay, so move it to the -7 on the y, then draw.
And then it'd just be the same line going straight through it.
Okay.
All right, y'all, the second transformation, that went up and down. The next one will be a horizontal shift. So horizontal shift is going to go left and right. So that's going to be y equals f of x plus or minus a. So the difference is I'm not adding a number at the end of the function. I'm actually changing the x value by adding or subtracting from it. Now, if a is positive, now this one's sort of backwards. You would think if I added a to my x, it would move it right, but this really moves it left. So if the a is positive, it's going to move my graph to the left. And if the a is negative, it's actually going to move my graph to the right. So y'all, let me show you the difference. So say I had y equals x plus 1 squared. So notice, while ago when I messed with that x squared, I had x squared and then I had plus or minus my number. But notice now, I'm changing what's actually being squared. I'm attacking that X. So when you attack that X like that inside the parentheses, that's going to move me left or right. So for this graph, this would move the X squared graph. Remember, I'm adding one, so it's actually going to move it to the left. So move the X squared graph left 1 unit. So when you attack that X is when it's going to go left or right. So let me subtract 1. So say I had an X minus 3 to the 3rd power. So this time I'm subtracting 3 from my X. So this is going to take the X cubed graph. So I'm going to move the X cube graph. Since I'm subtracting, we're going to move to the right. So this will go right 3 units. So if you added to the end, positive went up, negative went down. But when you attack them X's inside the parentheses, adding makes it go left, subtracting will make it go right. Y'all, the last move is what we call reflection over the x-axis. So that would be the form of y equals negative f of x. So if I throw a negative in front of my function, that's going to take my graph and flip it over the x-axis. So let's try a few of those. What if I had y equals negative x squared? So what this is going to do is it's going to reflect the x squared graph over the x-axis. So that one I'll draw for you. So my parabola was a U shape going up. When I reflect it, it's going to give me my U shape going down. So the power of that negative can reverse the whole graph and flip it over. It takes all the positive x value, all the positive y values and turns them all negative. So y'all, that's our 3 moves. We got the vertical shift, horizontal shift, and a reflection. So the best way to do these is to play with these on Math Lab, okay? So I'm actually going to share the homework page, and we're just going to go through all these problems and see what we'll do with them, okay? So let me share the Math Lab. Oh, hang on, I gotta pull it back up. Let me see. All right, so I think I'm on it now. So let me make sure my page is working. Okay. All right, so this is number 1. So first of all, we got to figure out which of those basic graphs it was. And I gave y'all 7 of them. But y'all, you see that exponent 2 there? That's telling me that this is going to be the x squared graph because I got an exponent of 2. So what I want to know is I'm attacking that x inside those parentheses and subtracting 1. So any guesses to what move that's going to do? Will that be up or down, left or right?
Move to the right.
Move to the right.
So it's going to move it to the right. So we would pick the one that says shift the graph 1 unit to the right, which would be C. And in the box where it says start with the graph of y equals, that's where we're going to have to put the x squared. So we're telling it we're starting with our x squared graph and we're going to shift it 1 unit to the right. So what happens is you come and check this answer because they're going to make us graph it. So y'all, we're going to click to enlarge our graph. So which tool would we use for the x squared graph? Well, y'all, that's going to be this U-shaped tool right here. So you're going to graph the x squared tool. Now you just click anywhere on the graph, it's going to put it in the middle. So we don't have to graph it. We just got to click on which one it is and then click the graph anywhere you want to. But down here, it opens up a box. Now, we're not going to worry about that stuff on the top. We're not going to do a vertical stretch and shrink. We're not going to do a horizontal stretch or shrink. What we're worried about is the vertical shift, horizontal shift, and then the reflect over the x-axis. Now, we'll never click reflect over the y-axis because we don't even reflect over the y-axis in this section. So y'all told me that would go right 1. So that's a horizontal shift. So what you got to do is come down here and grab this box on horizontal shift and move it right 1 unit. When you move that right 1 unit, it moves my graph right 1 unit. So notice the V of my graph is not in the center. It's moved over 1. So you would save that. So now it's made the graph, and all you do is check your answer by clicking yes. So y'all, I'm going to go back on that one again, and I'm going to do a similar exercise if it'll let me. All right, so I'm going to do this one again. So this is the same graph. That -9 is going to move me where?
Right.
Okay, so we're going to click A this time. Now remember, we're starting with our x squared graph. All right, you said 9 units to the right. Check the answer. And the reason I wanted y'all to see another one is this graph. So I'm going to click the U shape. I'm going to click anywhere on here. It's going to put it in the center. And this one, you'll be able to tell me move better because it's going right 9. So take that horizontal shift and move it over to a +9. So on this one, you can tell my graph definitely went right 9. So we're going to save that, check our answer.
Why is it going right 9? Do the sign in the middle not matter?
Well, what happens when you attack those x's like that? When you subtract 9 from your x, it actually moves the graph to the right instead of to the left.
Okay.
Now, if that would have been a +9, that would have moved it left and not right. Because what's happening is you're changing all the x values before you square it. And that's why it's sort of pulling it offline, okay?
This might sound dumb, but how do you know if it's like if you did the horizontal shift? How do you know when you're supposed to use the vertical one?
Okay, so let me find one real quick. So like this one here, you see how I got the 1/x graph?
Yes.
But notice I added 5 at the end. I didn't change the x any. I just added 5 to the end of that graph. So if I'd have took this number 1 up here, so let me show you the difference on that. And so I'm going to share my paper back. So let me show you this. So, and I'll do the same graph with the same numbers, just in different places. So the one I had just now, I had y equaled x minus 9 squared. And y'all told me this one went right 9. But what if I had y equals x squared minus 9? So notice the difference. This -9 is not in parentheses with my x. So it's not being squared like this part is. Over here, I just took the x squared graph and subtracted 9 from it. When I take the x squared graph and subtract 9 from the end of it, this one will move down 9 units. So the difference is, where am I placing that 9? Am I placing the 9 inside with the x before I square it? Or am I taking the x squared graph and just subtracting 9 from it? Is that making a little more sense?
So if you do anything with the x, you do horizontal, but if you don't, like if it's just -9, you go down, and if it's +9, you go up.
There you go.
Okay.
So here, if you notice, the numbers are in parentheses with the x. So the number here, number is in parentheses with the x. Here, the number is outside the parentheses. So let's just play with this by hand for a second. So what if I had y equaled, how about x plus 2 squared? So I want y'all to see, how come this thing's moving? Now let me do the normal x squared graph. So we're just going to look at the normal graph first. We're going to attack the x, and then we're going to come down here, and we're just going to add 2 to the end of the graph and see what that one does. So the x squared graph, and we'll just use numbers like -2, -1, 0, 1, and 2. So I just want y'all to sort of see what's happening to these values. So y'all, if you put a -2 into this one, -2 times -2 is a +4. If you put a -1 in, -1 times -1 is a +1. If I put a 0 in, 0 times 0 is 0. Now remember, these are symmetric, so the right half will get the same answers as I did on my left side. 1 squared, 1 times 1 is 1. And then if I put that 2 in, 2 squared would be 4. So this is the basic graph that started at 0, went to 1, 1, 2, 4, and so on. So it looks like our basic graph. So let me show you what happens when I put a +2 inside those parentheses. And yo, I'm going to still use my same numbers here. All right, y'all, but let's start out by putting a -2 into these parentheses. If I put a -2 into parentheses, -2 plus 2 is 0. 0 squared is 0. If I put a -1 into parentheses, -1 plus 2 is 1. 1 squared is 1. If I put a 0 into parentheses, 0 plus 2 is 2. 2 squared is 4. If I put a 1 into parentheses, 1 plus 2 is 3. 3 squared is 9. And then finally, if I put a 2 in, 2 plus 2 is 4. 4 squared is 16. But y'all think about this. Over here, my y value was 0 happened when my x value was 0. But look at this one. my x value, my y value of 0 is now sitting over here at -2. And then at -1, I got 1. So this one sort of comes up like that. And then this left side will go up like that. So by attacking that x by adding 2, what did it do to my graph? Did it not, in fact, move me left 2 units? Because my graph was at 0 on 0, but now the y value of 0 is happening at -2, which is 2 units to the left. Now watch this one here. I'm going to do the same numbers. So if I put a -2 in here, -2 times -2 is 4. 4 plus 2 is 6. If I put a -1 in, -1 times -1 is 1, plus 2 gives me 3. If I put a 0 in, 0 squared is 0, plus 2 gives me 2. If I put a 1, 1 squared is 1, plus 2 gives me 3. If I put a 2 in, 2 squared is 4, plus 2 gives me 6. So look what it did to this graph. At 0 for the x, my y value is now a 2. And then I got 1, 3 over here, 2, 6. Over here, I got -1, 3, -2, 6. But notice what it do to my graph. When I added 2 to the end of the function, it actually moved my graph up 2. So does that sort of help y'all see why if I attack the x's, I'm going left or right? If I add the number at the end, it's going up or down. Does that help y'all a little?
Yes.
All right. All righty, y'all. So let's go back to our math lab and see what they got next. All right, so we did this one, so let's hit 2. So this one has g of x equals x minus 3. So that's going to be the x graph. And what that -3 do to it?
We can't see your math lab yet.
Oh, hold on. Okay, so let me share that. Did it not share for me? Are y'all seeing it now?
I can see it.
Yes.
Okay. Okay. So it's saying describe how the graph of g of x equals x minus 3 can be obtained from one of the basic graphs. So since we got a single x there, that's going to be the y equals x graph. So y'all, what that -3 do to it? So remember, I'm adding and subtracting from the end of the function.
It moved it down.
All righty, so we would go to B, and we would say we started with the graph of y equals x. We shifted it down 3 units and check the answer. Now remember, the only trick, this is the only one where you actually have to graph it. And you're not going to have that little box open. So on this one, I would just grab my line tool. So this was y equals x minus 3. So if x is 0, the y value would be -3. So come to 0, -3. Click that first. And then let's say I made my x 3. So that'd be 3 minus 3, which is 0. So I would go to 3, 0. This one, you have to physically graph the 2 points when it's the line. But notice, the line's not going through the center no more. It's actually moved down 3 units. So you save that one, and then you check your answer. So the straight X line is the only one where you actually got to plot the 2 points, okay? Everything else, we're going to have to move them and do all that fun stuff. So this one has h of x equals 1 over x plus 4. And they're telling you it's going to start with that 1 over x graph we looked at. So they're adding 4 to the end. So y'all, what's that doing to my graph? Right, left, down, or up?
Up.
Up. So we would pick D. Check that answer. Now they're going to make us figure out which one of these looks like it went up, A, B, or C. And I'll tell you this, C is the basic graph.
A.
A or B, so y'all said A, so that went up. So this one you didn't have to graph, you just had to pick your picture. So remember, A went up, B went down, C is the actual basic graph, okay? These aren't too bad once you get used to playing with that math lab. So y'all look at this. I got a negative x plus 1 in parentheses raised to the 3rd power. So this is going to be the x cubed graph. So the first thing I want to know, I added 1 to the x. What's that going to do?
To the right.
Oh, you're so close.
Oh, to the left.
To the left. There you go. And then you see that negative in the front? What's that negative going to do?
Go down.
Well, that negative in the front, remember, if I put a negative in front of my function, that's going to reflect me. And the
Over
only axis we're reflecting anything over in this section is the x-axis. So we would go with B because it's going to shift it 1 unit to the left. And then remember, the negative is only going to reflect it over that x-axis. And y'all, since we see that exponent of a 3 there, this will be the x to the 3rd graph. Okay, so inside the parentheses, remember, I added 1, that moved me left. And then the negative in the very front reflects this over the x-axis. So y'all are going to have to check this and then graph it. So click to enlarge my graph. Y'all remember the x cubed graphs is the 2nd row, 2nd graph. When you click on it, it says x cubed tool. So click that and then click anywhere on the graph. It's going to put it in the center and open the box. So y'all told me this went left 1. So we're going to take the horizontal shift and move it to -1. That moved my graph 1. Now look on the bottom, you see a box that says reflect over the x-axis. Now watch my graph when I click that. My graph was going uphill. When I click that, it's now going downhill left to right. So move the horizontal -1, click, reflect over the x-axis. Then you save that, check your answer. Oh, I got a fun one here. So let's see what we're going to do to this, y'all. I got g of x equals x plus 3 squared minus 4. So we'll figure this one out, and then we'll take our break. So you see an x squared, a 2 for the exponent. So that means we're going to start with the graph of x squared. All right, so then it says shift it blank 3 units. So y'all, that 3 is inside those parentheses and it's positive. So what's that doing to my graph? And your choices are right, down, up, and left.
left.
So it's definitely going left 3 units. And then it says, and then shift it blank 4 units. So the 4 is at the end being subtracted. So up, left, down, or right?
Down.
Down, there you go. And that's the difference. When I'm inside the parentheses, left or right. When I'm outside at the end, up or down. All right, y'all, so let's check that. And then they're probably going to make us graph this. Right, so I'm gonna click to enlarge my graph. All right, so we started with the x squared graph, so that's going to be the U-shaped x squared tool. Click it, click anywhere on the graph. All right, the +3 made us go left 3, y'all said. So the horizontal, I'm going to move that over to -3. And then, oh, what was my number at the end? I couldn't remember. I got a block.
4.
So it's +4, right? Or -4?
If you just like, yeah, you can
Okay,
-4.
a -4. So that'd be my vertical shift. I'm going to move that to -4. So notice it's moved my graph left and down. So now we save that. Then we'll check our answer. All right, y'all. So let's take our break. We'll start about, what is it right now? About 11. So how about 10 after 11? We'll finish this out. Any questions before we break? All righty, so I'm going to pause this real quick. All right, so I'm going to share my screen back to the math lab. All right, y'all, describe how this one can be obtained and graph it. And they're telling us we're starting with the graph of the square root of x. So y'all, since that x minus 10 is all up under that square root, we would treat it like it's in parentheses. So since that 10 is being subtracted, right, down, left, or up. And remember, since it's like it's in parentheses, and
Right.
it's going to be right. There you go. And then we got to put in our 10. So it's going to shift it right 10 units. We'll check that. So this one, which one looks like it went right? A, B, C, or D? Now remember, this is a square root. It always starts in the origin in the center. So A looks like it went down. B looks like it went up.
D.
You said D, there you go, because that looks like it went to the right. And then C looks like it went left. So we go with D on that one. Check our answer. All righty, they're telling you we're starting with a cube root of x graph, and they want to know what happens when we do a cube root of x minus 6. And y'all, the difference between this one and the last one, that -6 is not under that cube root radical. So it's like you're adding or subtracting to the end of the function. So A, B, C, or D, up, down, right, or left?
B.
So I think you said B is in boy.
Yes.
Right, so that moved me down 6. So we check that. So which graph looks like it went down? And I'll tell you, B is the basic graph. So it's either going to be A or C.
A.
So A, I'm going to click A because it went down, and then C looks like it went up. So A went down actually. So check that one. And y'all look at this, the last one. And then, oh, we don't even have to graph this one. They just want to know what happens. So we're going to start with the x squared graph because we got that exponent 2 there. First thing we got to do is look at, it's either wanting me to go left 6, left 4, right 6. So they're focusing on the inside of the parentheses. So you're sort of going to work these like you would order of operations. Work inside the parentheses first. X minus 4. What is that minus 4 doing to my graph? It's either going to go left 4 or right 4.
Right.
All righty, so I'm going to go. So it's going to go right 4. So remember, left and right are sort of backwards from what you would think they would be on this. And then it says reflected across the x-axis or the y-axis. Well, y'all, there's only one y'all been reflecting across, and that's going to be the x-axis. Never, on none of these 8 questions, never pick y-axis. We're only reflecting over the x. All right, y'all, and at the end, it's got a +6. So is that down 6, up 6, down 4, up 4?
6.
Up.
Up 6. There you go. Okay, so then you check that answer and y'all are done. So do y'all need to see any of those again, or are y'all good on those?
I was following along with you with the homework, but 5 and 7, I seem to like get one correct and one incorrect. So I would get the first question correct, but when it came to the graph, I would get it wrong.
Uh-huh.
So I'm confused on
Okay.
what.
So do you got access to your homework right now?
Yes.
Okay, so I'm going to stop my share here. I'm going to enable y'all to share your screen with me. Okay, so I got it enabled. So share me your screen with those problems and we're about to get you fixed.
Okay.
And so if y'all need to share, there should be a share screen button on the bottom of y'all's screen.
Okay, hold on.
Mm-hmm. And then when you click that share screen, you got to click which one of the screens you want to share on your it'll show all the screens and you can pick one of those to share with me.
Okay, can you see it?
Mm-hmm.
Can you still see it?
Yeah, I see it. So you got a problem. It looks like g of x equals x plus 2 squared plus 5.
Yeah. And with the graph, I guess this is what I put as the point at first.
Uh-huh.
But it confused me, I guess, because I'm graphing it how I'm reading it.
Okay,
And
so let me see what you got. You got an x plus 2 squared plus 5. So you started with the graph of x squared, shifted it left 2 units, and then shifted up 5. So that is perfect. So let's click on our graph and see what's happening. All right, so clear that one. So pick your U-shaped parabola looking tool. Yep, and then click anywhere on the graph. All right, so start with your +2. You said you went left twice. So take that horizontal shift and move it to -2.
okay, that's what I did wrong. I switched the vertical shift to -2.
Oh, okay. So your vertical should be +5. So move that vertical to your +5.
Okay.
All right, so it's moved it up and down. So you'll save that. And then final check.
Okay. I guess that's the same thing I did on 7 then.
Well, let's see what you got on 7. So that one is a cube root of x plus 3. So hit similar question. Let's get this fixed. All right, so now it is a cube root of x minus 5. So that -5 at the end of it is going to move your graph up or down. So remember, when you subtract 5 at the end, it's going to move me down 5 units. So let's see, what's that? That looks like B for you. And then you'll check that answer.
Mhm.
Now, which one of those graphs looks like it went down 5? So A is the actual basic graph.
C.
Yeah, I think you're there. Yeah, click that C and then final check.
Okay.
So that's all. You just that thing. Remember, the vertical up and down, that horizontal will be your left and right.
Okay, I got it. Thank you so much.
Alrighty. Alrighty, y'all. Anyone else got questions on that? All right. So what I'm going to do? Let me see what my chat says. Okay, so Michelle, yeah, I haven't gotten anything yet, but you probably got something you can email me about that, okay? So what problem do you need, Michelle?
I think it's one that's on